What happens when you collide something that technically should not even exist? This is not just a science question. It feels like a puzzle made for philosophy, a riddle about the universe itself. Yet today, this is no longer only an idea to think about. It is something scientists are beginning to test. At Fermab, one of the most advanced particle physics labs in the world, researchers are moving beyond ordinary experiments. They are trying to do the impossible: collide a dark photon. The dark photon is not like the normal particles we know. It is still only a theory, a hidden particle that might explain the strange mystery of dark matter. Dark matter makes up most of the universe, but we cannot see it or touch it. We only know it is there because its gravity pulls on galaxies and stars. If the dark photon is real, it could be the bridge to this unseen world. This is why the question matters. It is not just about numbers on a chalkboard. It is about daring to collide a ghost, to create a spark from something that may not even belong to our reality. But with this daring comes fear. Scientists warn that chasing such an idea could open doors we may never close again. When you push at the edges of reality itself, the answers you find might be more dangerous than the questions you started with. Crossing physics and philosophy, the dark photon is not just a theory inside physics. It is also a mirror that reflects deep questions about existence. When Fermab scientists push their machines to collide something that might not even exist, they are no longer working only inside the walls of physics. They are stepping into philosophy, into the timeless question of whether humans should explore every door they find. On one side, this search is pure science: measure, test, and learn. On the other, it is a challenge to meaning itself. What happens if the rules that keep the universe stable are not as unbreakable as we thought? This is why physicists and ethicists argue together. To some, the experiment is only a bold way to test theories. To others, it risks pressing against the hidden code that makes reality safe and balanced. It is no longer just about particles or data. It is about the right to shake the universe and see what falls. Should humanity carry that weight, or should we step back before curiosity becomes danger? Here, physics meets philosophy in its rawest form. It asks not only can we, but also should we. Every test may bring us closer to truth, or to chaos. At Fermab, the line between discovery and risk is thin, and crossing it could reshape how we see not just the cosmos, but our own responsibility within it. Fermab pushes new boundaries at Fermab. The pursuit of knowledge has reached a level once thought impossible. For decades, particle accelerators have collided protons, electrons, and photons, revealing hidden layers of the universe. But now, Fermab scientists are aiming for something far more daring: the collision of dark photons. Unlike ordinary matter, dark photons belong to the hidden sector, a shadow world tied to dark matter. Moving this idea from pure theory to active experiment marks a historic moment. It is not just science inching forward. It is science leaping across a boundary no one expected to cross so soon. To achieve this, Fermab has designed advanced superconducting cavities, chilled to near absolute zero, to force ordinary photons into extreme conditions. In this fragile and highly controlled environment, even the faintest interaction with a dark photon could leave a trace. This work pushes technology, precision, and human imagination to their limits. Yet pushing boundaries also means testing safety. Every new frontier in physics, atomic energy, quantum mechanics, black holes, first inspired fear before acceptance. Now Fermab faces the same scrutiny. Supporters call it bold progress. Critics call it reckless. But one truth remains: humanity is standing at a scientific edge, and Fermab is leading the step forward. The dark photon idea. The dark photon begins as a whisper in theory, a particle that should not exist in the ordinary sense, but might explain the unseen mass holding the universe together. Just as the photon carries light, the dark photon is thought to carry a hidden force linked to dark matter. dark matter is invisible, cannot be touched, and gives off no light. Yet it shapes galaxies, bends starlight, and makes up most of the cosmos. If dark photons are real, they could be the key to unlocking this mystery. At Fermab, this idea has moved from blackboards to powerful machines. Scientists are firing photons into ultra-cold cavities, hoping they will transform, even for the briefest moment, into dark photons. If such a shift is detected, it would confirm that the hidden sector is not just imagination, but a real part of nature. It would mean our visible universe is not alone, but tied to a deeper structure of forces we barely understand. But here lies the paradox. To prove the dark photon exists, humanity must test the very limits of physics. Each trial is like tapping on the walls of reality, waiting to hear a hollow sound that reveals a secret passage. It is daring, brilliant, and dangerous all at once. The dark photon idea is not just science. It is a door to a hidden universe, and once opened, there may be no turning back. A leap into the unknown. Colliding a dark photon is not like testing a new engine or building a faster computer. It is stepping into territory where no map exists. Most experiments in science expand what we already know, adding details, sharpening ideas, confirming or disproving predictions. But Fermab's dark photon search is different. It is a leap into the unknown, where the consequences cannot be fully predicted. Success might uncover new physics, a hidden force, even an entire sector of reality. But failure does not simply mean no result. It could mean unexpected ripples, strange effects, or outcomes beyond imagination. This is why so many experts describe the project as walking a razor's edge. On one side lies immense knowledge, answers to dark matter, the unseen scaffolding of the universe, and perhaps a fifth fundamental force. On the other side lies risk, disturbing the balance of natural laws that hold galaxies, stars, and even atoms together. The stakes are cosmic, yet the experiment takes place in a single underground lab. Every photon slammed into the superconducting cavity carries a question: will the universe answer in silence? Or will it reveal something we are not ready for? This is the meaning of a leap into the unknown. Humanity is reaching not just for knowledge, but for the threads that weave reality itself. And once pulled, those threads may never be the same again. Fears of breaking reality. Not everyone sees Fermab's dark photon experiment as progress. For many scientists and ethicists, it raises a chilling concern. What if colliding something that should not exist risks unraveling the very rules of reality? The fear is not about explosions or fire. It is deeper. If dark photons can touch ordinary matter, they might reveal hidden forces strong enough to rewrite the laws we trust every day. Gravity, electromagnetism, the way galaxies form. What if all of it shifts under the weight of this discovery? The nightmare is simple, but terrifying. By disturbing the dark sector, we could destabilize the cosmic balance that holds everything together. Some researchers warn that even a tiny resonance, a faint echo inside a detector, could point to forces powerful enough to reshape the universe. This is why the debate feels so urgent. The choice to push forward is not just about science. It is about gambling with the stability of existence itself. History reminds us of fears during the birth of nuclear physics, or when the Large Hadron Collider was accused of making black holes. Those fears proved false, but they left scars of doubt. Now, the same shadow hangs over dark photon research. Each test at Fermab asks the same unspoken question: are we unlocking knowledge, or are we striking cracks into the foundation of reality? Ethics of playing with nature. The search for the dark photon is not only a scientific challenge, it is an ethical one. Humanity now has the power to tamper with forces that may shape the very fabric of the cosmos. The question is no longer just, can we do this? But should we? At Fermab, some scientists argue that the risks are worth it, because knowledge of the dark sector could explain the greatest mysteries of the universe. Others warn that curiosity, without restraint can be dangerous, especially when the experiments reach into areas of physics we barely understand. This is the old debate of playing God. Reborn. Just as nuclear research once forced humanity to weigh progress against destruction, today's particle experiments push us to reflect on our limits. When we build machines capable of shaking reality itself, we must ask who decides how far to go. Is it the duty of science to push every boundary, or does society need to draw a line before discovery becomes threat? The ethics of playing with nature demand more than technical skill. They require humility, wisdom, and a sense of responsibility for the consequences. Every experiment is a choice, and every choice carries risk, not just for scientists but for everyone alive under the same stars. Dark photon research forces humanity to face this truth. Sometimes the cost of knowledge is not just data, but the safety of reality itself. Standing on the edge of knowledge, humanity has always pushed toward the unknown. Sailing beyond maps, peering through new telescopes, splitting the atom. Each step carried risk, yet also unlocked new worlds of understanding. Fermab's dark photon experiment is the newest edge of that long journey. It is not just science. It is standing at the cliff of what we know, looking into a fog where the future is unclear. The edge is both thrilling and terrifying, because one step forward could reveal wonders, or it could bring consequences we cannot control. The experiment is like holding a key in your hand. You know it can open a door, but you do not know what waits on the other side. Perhaps the room is full of answers. Dark matter explained, hidden forces revealed, a new layer of physics uncovered, or perhaps the room holds dangers that cannot be shut away once released. This is why so many describe Fermab's work as walking a razor's edge. The rewards are immense, but the risks are equally vast. At this boundary, the question becomes deeply human. Do we dare to take the step? Do we accept that discovery often means danger? Or do we pause, fearing that some doors were never meant to be opened? Standing on the edge of knowledge means facing the weight of that choice. Forcing reality to answer, the dark photon experiment at Fermab is not passive observation. It is confrontation. Scientists are not waiting for the universe to reveal its secrets naturally. They are pushing, pressing, and forcing reality into a corner where it must answer. In superconducting chambers chilled to near absolute zero, ordinary photons are slammed again and again, compelled to transform into their mysterious shadow counterparts. It is like shaking the foundations of a great wall, waiting to hear even the faintest crack. That crack, if it comes, would be proof that the hidden world of dark matter touches our own. This method is both elegant and unsettling. Elegant because it uses precision, control, and the sharpest technology humanity has ever built. Unsettling because it reveals the boldness of our species to demand answers from existence itself, even when those answers may frighten us. If the photons shift, even for a fraction of a second, it could prove that a hidden force has always been with us, unseen but shaping everything. To force reality to answer is to risk what kind of answer we may receive. Silence could mean we are wrong. A signal could mean we have unlocked an entirely new chapter of physics. But there is always the chance that the answer will be bigger, stranger, and more dangerous than we imagined. Shaking the cosmic scaffolding, to imagine what Fermab is doing, picture the universe as a vast cathedral of stars. Every galaxy, every planet, every particle hangs in place because of an invisible scaffolding, dark matter and dark energy. Though unseen, this hidden framework holds everything together. The dark photon experiment is like reaching out and giving that scaffolding a careful shake, listening for even the slightest rattle. If a tremor is detected, it would prove that our visible universe is tied directly to a shadow world of forces we have never seen. This image shows why the experiment feels so delicate and so dangerous. On one hand, a gentle shake may reveal cracks of truth, opening the way to answers about why galaxies hold their shape or why the cosmos expands. On the other, disturbing this invisible framework could carry risks we cannot fully predict. What if the scaffolding wobbles more than expected? What if it reveals hidden strengths or hidden weaknesses that challenge everything we think we know? Fermab's work is not about tearing the universe apart. It is about testing the silent structure beneath it. But like tapping on the foundation of a skyscraper, the act itself is bold, unsettling, and full of consequence. Even the smallest rattle could change our understanding of reality forever. Hidden forces at play. If dark photons exist, they are not just quiet shadows. They could be carriers of a hidden force, one powerful enough to influence the universe in ways we cannot yet see. Our physics is built on four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. But what if there is a fifth, invisible force binding reality from the shadows? Fermab's dark photon search is not just about finding a particle. It is about asking if the laws of the cosmos are incomplete. This possibility excites and terrifies researchers alike. A new hidden force could explain why galaxies stay together, why dark matter refuses to be seen, or even why the universe expands the way it does. Yet, it also raises questions of control. If such a force can touch our world, could it also be tapped, shaped, or even weaponized? That thought unsettles ethicists who warn that discovering hidden forces may tempt humanity to use them before truly understanding them. For now, the forces remain only whispers, tiny anomalies, faint signals that might one day prove real. But even whispers carry weight. If revealed, hidden forces would reshape science, technology, and even philosophy. They would remind us that the universe is not finished in its design, but still holding secrets powerful enough to change everything. Testing the fabric of existence. What Fermab is doing is more than a physics test. It is a direct probe into the fabric of existence itself. Every law we know, from the pull of gravity to the spin of particles, is woven into a delicate pattern that makes reality stable. By colliding photons in ultra-cold superconducting chambers, scientists are not just measuring, they are tugging at those threads, seeing if they connect to something deeper. If a dark photon is revealed, it would mean the fabric is more complex than we imagined, stitched with hidden layers that bind our universe to an unseen one. This is why the experiment feels so monumental. Most scientific work studies the details of the design. This goes after the foundation. It asks, what is the universe really made of? Could it unravel, or could it reveal a stronger weave we never knew existed? Every measurement, every silence, every faint anomaly is a clue. But such testing is not without fear. To pull at the fabric is to risk fraying it, even in ways we cannot predict. Supporters believe the universe is resilient, that it will reveal secrets without harm. Critics fear that once disturbed, some patterns may never return to balance. Testing the fabric of existence means accepting both possibilities and daring to move forward anyway. Whispers of new physics. Every great leap in science has begun as a whisper, a faint clue that something beyond our understanding is waiting to be found. For Fermab's dark photon experiment, those whispers could come as tiny resonances, strange echoes inside detectors, or anomalies too subtle to dismiss. These signs would not be explosions of proof, but quiet hints that the standard model of physics, our most trusted map of reality, is incomplete. The whispers are what physicists chase, because even the smallest irregularity could signal the doorway to new physics. Imagine listening in a vast silent hall. You expect stillness, yet suddenly you hear the faintest creak. That creak tells you the structure is alive, full of hidden tension. The dark photon, if it exists, would be that creak in the cosmic framework. Subtle but undeniable. It would say, there is more here than you know. For some, these whispers promise hope, answers about dark matter, hidden forces, and the true design of the universe. For others, they carry unease. What if the new physics reshapes everything we thought was stable? Every whisper brings excitement, but also the weight of responsibility. Because once whispers become voices, the world will never sound the same again. A fifth force revealed. Our universe rests on four known pillars: gravity, electromagnetism, the strong force, and the weak force. These four rules shape everything, from the fall of an apple to the birth of stars. But what if there is a hidden fifth force, one carried by the dark photon? That is the question Fermab's experiment is daring to ask. If proven real, this discovery would not simply add a new chapter to physics. It would rewrite the entire book. A fifth force could explain the mysteries that have long haunted science. Why does dark matter hold galaxies together but remain invisible? Why does the universe expand faster than expected? Why do certain cosmic structures behave in ways that math cannot explain? The dark photon might be the messenger of this hidden force, quietly shaping reality without our knowledge. The implications are staggering. Technology could one day harness such a force, leading to unimaginable breakthroughs or dangers. Philosophy would change too, as humanity realizes the universe has rules we never even knew existed. For now, it remains only a question. But if Fermab finds proof, the answer would shake every corner of science. A fifth force revealed would mean that our map of reality has been missing its most important path all along. Cracks in the cosmic model for decades, scientists have trusted the KINCDM model, our standard map of cosmology. It explains how galaxies form, how the universe expands, and how dark matter and dark energy fit into the grand design. But if dark photons exist and carry a hidden force, that map could begin to crack. The invisible scaffolding of the cosmos might not behave the way we thought. Galaxies could be held together by rules more complex than gravity alone, and the universe's expansion might be driven by forces we never imagined. This is why Fermab's search is so unsettling. It does not simply test small details. It threatens the entire foundation of our cosmic story. A single anomaly, a faint resonance suggesting dark photons are real, could force scientists to rewrite equations that once seemed unshakable. The standard model of physics and cosmology has guided generations, but its limits are now in sight. These cracks are not failures. They are opportunities. They show that our understanding, while powerful, is incomplete. Yet with opportunity comes risk. What if the cracks widen into fractures, revealing a universe stranger and less stable than we believed? To peer into these cracks is to admit we might be wrong about everything, and to embrace the possibility of starting anew. Personal stakes of discovery. It is easy to see Fermab's dark photon experiment as abstract science, a pursuit of particles far removed from daily life. But the stakes are deeply personal. If dark photons exist, their hidden force could reshape not just cosmology but technology, energy, and even the way humanity survives in the future. Imagine new methods of power generation that draw from this unseen force, or communication systems that bypass limits of space and time. Such advances could change economies, societies, and the balance of power across the world. Yet personal stakes also include fear. What if meddling with the dark sector triggers effects we cannot contain? What if by unlocking this new physics, we also create risks, dangers too large for any government or scientist to control? For ethicists, this raises questions not of curiosity, but of responsibility. Every discovery carries consequences, and those consequences fall on all of us, not just the ones inside the lab. The dark photon is not only a scientific riddle, it is a mirror reflecting humanity's choice. Do we accept the risks for the chance at a brighter future, or do we hesitate, fearing the cost could be greater than we can bear? In this way, the search is not distant at all. It is about us, our children, and the kind of world we will leave behind. Playing God debate returns. Whenever humanity reaches too far, the same warning rises. Don't play God. It echoed when nuclear physics gave birth to atomic power. It surfaced again when the Large Hadron Collider was accused of creating black holes. and now it returns with Fermab's dark photon search. To some, colliding particles that may not even exist feels like tampering with the code of reality itself. If nature wrote rules to keep the universe stable, are we now hacking those rules? And if so, are we prepared for the consequences when errors appear? Supporters argue this is not arrogance but progress. They say every great leap in